Hello everyone. Today's episode comes as a request from @user-EW5QK2MU3V. A great name. This fine fellow wanted to hear about Enhydros. So just what is an enhydro? Well, it's a little hard to talk about enhydros without simultaneously talking about the secondary topic of this episode, fluid inclusions. So I'm going to kind of explain both at the same time. So both an enhydro and a fluid inclusion are water trapped inside a crystal. So what's the difference? An enhydro is microcrystalline quartz containing water, while a fluid inclusion is a bubble of water or other fluid trapped inside a crystal during formation. The water inside a fluid inclusion has been trapped there since the crystal formed, as the water has no way to get in or out. On the other hand, the microcrystalline shell of the enhydro is permeable, so water can still pass in and out, albeit rather slowly, but this means the water in an enhydro is usually not the water that was present during its formation. Now that we've discussed what they are, let's talk about how they form. Enhydros form when silica-rich water percolates through volcanic rock. The silica exits the water and forms layers of microcrystalline silica as the water goes through. When the silica-bearing water reaches a cavity in the rock, the silica layers end up trapping the water within, forming the enhydro. Fluid inclusions, on the other hand, form differently. Liquid rock contains water vapor and other gases. As it cools and forms mineral crystals, bubbles of water and other fluids can be trapped within the crystals. These fluids have no means of escaping the now solid crystal and are trapped. These bubbles are extremely small, often invisible to the naked eye, and impossible to study without a microscope. Inclusions in igneous minerals can give us information about the magma's original composition, as well as some stuff about deformation history of the region. Fluid inclusions can also be trapped during the formation of amber, and air bubbles may be trapped in glacial ice. These trapped bubbles of air and water can give us information on ancient climates, as well as prehistoric seawater and atmospheric compositions. So yeah, kind of a short episode today, but that's the gist of enhydros and fluid inclusions. I know I talked a lot today about microcrystalline silica without ever really explaining what it is, but don't worry, I will get into a better explanation of that in a future episode when we talk about quartz. But anyway, that's all I got for you today. If you enjoyed this episode, please leave a like and maybe even consider subscribing. I really do appreciate it. And if you'd like to suggest a topic for a future episode, leave a comment. Till next time.